Sample problem. Mercury salts have a number of important uses in industry and in chemical analysis. Because mercury compounds are poisonous, however, the mercury ions must be removed from the waste water. Suppose that 25.00 milliliters of 0.0850 moles per liter aqueous of sodium sulfide is added to 56.5 milliliters of 0.100 moles per liter of mercury 2 nitrate. What mass of mercury 2 sulfide precipitates? To help you guys out, here is the equation you're going to start off with. So take a moment and devise a plan. Think about what you're given. Think about the information that you're given. Right? If you need space, make sure you leave enough space on your paper to kind of work things out. Right? Take that and then start, underneath each one of the compounds, start labeling all the information that you're given. See what you can figure out. Our question has volume and concentration of sodium sulfide, and same thing, volume and concentration of the mercury nitrate. So what we want to do is we want to find the number of moles of each one of our reactants. So let's look at the mercury here. Right? The HgNO3 2. So what we have is 0.0565 liters. So what I've done is I've converted 56.5 milliliters into liters, and we're going to multiply it by the concentration, which is 0.100 moles per liter. And it will give me 0.00565 moles. We're going to do the same thing now with the sodium sulfide, the Na2S. And again, we're going to convert the volume, 25.00 milliliters, into liters, and we get 0.050 liters. And we're going to multiply it by the concentration, which is 0.0850 moles per liter. Right? Liters cancel out. I'm left with the answer of moles, which is 0.00212 moles. Now, question asks, what mass of mercury 2 sulfide precipitates? We're trying to find the number of moles of the mercury sulfide. In order to do that, I've got the number of moles that I'm using between my reactants. Right? I'm going to use this many moles and this many moles. When will the reaction stop? What is the limiting reactant? Pardon? The Na2S, right? Because the least number of moles, right? Once we run out of that, that's it. The reaction stops. So the limiting reactant will be that. Now, because that's the limiting reactant, if we use this, right? Our given, right? Our unknown is the HGS. We want to find the number of moles, right, of the mercury 2 sulfide. The given is going to be based on the limiting reactant, right? We can't have more moles than 0.00212, right, for moles, molecules. But what is the ratio between those two? 1 to 1. So because it's a 1 to 1 ratio, the number of moles, right, if we're using this many moles of sodium sulfide, we're going to have that many moles of mercury 2 sulfide. Right? So the X of the mercury 2 sulfide is 0.00212 moles. Right? Why? 1 to 1 ratio, right? So we don't have to worry about making any calculation. So we know we have that many moles, right? We want to find the mass of mercury 2 sulfide. We know the number of moles, so what are we going to try to find now? The molar mass, right? The molar mass of the mercury 2 sulfide is, so we've got the number of moles, so 0.00212 moles. And we're going to multiply it by the molar mass, and the molar mass is 232.7 grams per mole. Moles cancel out. All I'm left with is grams, and the number of grams. Okay, so the mass of the HGS, the mercury 2 sulfide, is 0.493 grams. Least number of significant digits in my question are 3, so that is my final answer.